Just a few notes before we get started. This file you need today. I'm going over some assignments to do some examples. And then you have one of the worksheets. There's 3 worksheets here if you see along the bottom. In your version of Minitab, sometimes these worksheets like to disappear on you. So sometimes you need to go to View and click on View, and then you can change your view for seeing more of the worksheets and how you customize the toolbar and stuff like that. So you may have to play with that. In your version of Minitab, also there's a tab called Window, and if you click on Window, you can then select which worksheet is open and which graph is open and things like that. So those are some things that are different in Minitab 18 compared to what I'm using, which might be helpful. But you need all 3 worksheets. Well, today we'll do worksheet 1 that's associated with the examples, but for the case study 3, you're going to need this file, and for your homework for chapter 11, you need this file. So I will post this file again in next week's folder for case study 3. I sent an announcement out, but just a reminder, thank you for everyone who voted on the Google Doc, the Google form. The overwhelming majority wanted this week to just be chapter 11, so it's just the chapter 11 lecture and homework. Then next week, it will be, the case study will be posted. And again, this will be the Minitab document, and then you'll have a case study worksheet that will look remarkably similar to what you're working with today for the case study. And then I will do a synchronous Zoom and record it for studying for exam 3. Exam 3 is our only other exam. There is no final. It is non-cumulative, so it will only be covering, it will exclusively be done on Minitab. It won't use Proctorio, it won't be timed, it will be a Word document that you open and an Excel file for you to copy and paste data into Minitab while you're on the remote lab. So definitely don't leave it for the last minute in case you were to ever have issues with the remote lab. You don't want to have issues, but it's all in Minitab. So our synchronous Zoom will go over those functions in Minitab again. And so we'll review hypothesis testing, which we talked about last week. We'll go back to a few of those graphing options and how they relate to hypothesis testing, like how those graphical options can help us understand better the data in front of us. And then, of course, the work that we're doing today will also be a part of that exam. But we will not be doing chapter 13. We will not be doing any sort of ANOVA. So if you have questions, I know the schedule has been fluid. That's not to frustrate you, that's to try to make things easier on you as we go through this and just try to get through this semester. But with all the changes, I understand it might be hard to keep up sometimes, so please feel free to ask me any questions that you have. Are there any questions before we get started on using Minitab for linear regression that you might have, just regarding the course or anything like that? Anybody want to flip me a thumbs up in their chat box or something? I'm just watching Derek eat his breakfast right now. Derek gave me a thumbs up. Okay, thanks, Evan. I got another thumbs up. There we go. All right, so jumping right in. Thank you, Lily, and Baby Yoda for the thumbs up. Lily has a Baby Yoda. I don't know if that's what you guys see, but if you know me and you've ever been into my office for the few weeks we were actually on campus this semester, I've got a Baby Yoda on my desk. So I appreciate that, Lily. Thank you. So what we're going to do is we're going to do 2 examples, and I've got my dock camera, which hopefully will work. I'll share that as well to look at how this should look on the actual case study and on your exam and on your homework, how you'll actually complete the homework assignments. So I've got it printed out and blank so that we can just work through it together. But the first place you start is Minitab, because you need to actually get the answers. So we start out going to the Stat tab and go to regression, and we're going to fit regression model. This may be slightly different than your options in Minitab 18, but it should still be the under basic statistics should be regression, and then you're going to fit the regression model. And so you get this box, and this box is the make or break of the entire assignment, because in this box you have to decide what is X and what is Y. And I think one of your homework assignments, I'm going to click here on worksheet 2. I can't with that open. I think one of your homework assignments just gives you X and Y. Most of the time it doesn't. Most of the time it's a word problem and you have to decide. And the thing that is important to remember, and that's why I have it on the worksheet, is the response variable is Y, and you're solving for Y with respect to X. Now, obviously, with a linear equation, 2 variables and only one being unknown, if you had a Y, you could solve for the X. If you had an X, you can solve for the Y. But the basic function in Minitab to set up is that your X, your predictor, is your X variable and your response variable is your Y. And that language is important because the output that you get from Minitab doesn't just say X and Y, and it doesn't even necessarily use the variable names. And you'll see that in a second. So it's important to make sure you're clear in your mind what it is that you're looking at, what is your X and what is your Y. And in fact, the first question in your worksheet is what is the predictor and what is the response variable? And it's just to make sure that you're understanding what information is going where. So the question for this example says a realtor wants to build a model to determine sales price of a house based on property taxes. So the property tax is the predictor. That's what we're going to be looking at relating to the sales price, which is the response. So clicking in the response box, I click on sale because that's the sales price. And then clicking in the predictor box, I click on taxes and select taxes. You do not need categorical predictors. We're not doing regressions that have additional categories that are associated with them. That is covered later in Chapter 11, but it's not covered in our course. Again, that's a graduate level work that you would be doing. So our response and continuous predictors are there. Now, we're going to click through a few of these. When we look through our model, there's nothing really that we need to change with the model itself. In options, we're not going to do any sort of weights or transformations. It's always going to be two-sided. This adjusted type 3 sum of squares test, that is the standard, and that doesn't need to be changed either. The only thing that you guys would ever potentially change is the confidence interval. So if the problem says 95% confidence interval, that's the default. So you can just use it. You don't need to change anything. If it says a 90% confidence interval or a 99% confidence interval, this is the box where you would go to change that, and you would type that and change that there. For our graphs, we want to have a normal probability plot of the residuals, and we'll look at that. We talked about it a little in the other, the non-synchronous Zoom, but you want to go ahead and click that so that you have that available, and we'll talk about that. In your case study and homework, I actually have you copy and paste this into your results, so that you can do an analysis of that. So make sure that you go into the graphs and click normal probability plot so that it automatically pops up. So 95% confidence interval and the graph are the two ones that you really want to look at most frequently. For the results, you could choose to not have some of these things if you wanted to ignore some of them. I'm just leaving it all as the defaults, and we won't use every piece of data, but the data that is on your worksheet for the case study, for the homework, for the exam, as long as you leave the default setting, you will have all of the data that you need. So we hit OK, and it runs and gives us our worksheet. So as we're looking at this, a couple things that we want to immediately look at. So the regression equation is the first thing, and I'm going to see if I can screen share really quick. Switch to the camera. I'm going to need your help to tell me what you're seeing. There we go. Are you seeing my document now?
Yep.
Thank you. Okay. So this is what you will see for homework, case studies, exams, is all of these questions. The only thing that I don't have included on here is I don't have the question where it says that you need to go ahead and copy and paste the plot of the residuals, because I didn't require that before. We were doing it in class last semester, and so I didn't do that. But this time, since we're doing it online, I want to make sure that you're accessing that data and analyzing it. So again, the first question says, what is a predictor and what is a response variable? So what I expect you to write is I expect you to write predictor equals taxes, right? Because that's what we're using to predict, and the response equals sales. That's all you have to write. Then down here, I sometimes find it helpful to just write that again on my sheet so that I remember what it is I'm talking about. So sales is my response. So when I look at the intercept for that, the coefficient, the standard error, the p-value, I know that I'm looking at the sales line. Predictor is the taxes. And so again, that's useful for me to know. And so that just kind of helps me to remember what it is I'm looking at when I'm looking at all this data. So I ask for the data that's going to be given in Minitab for the coefficient for both B0 and B1. So if you remember from the lecture video, we have the y-intercept and the slope, because all of this is based on our classic, third grade y equals mx plus b formula. And so our intercept and our slope both have coefficients that are used in the regression equation. There's the standard error of the coefficients, which shows the reliability. There's the p-value. And remember, the null hypothesis is that there is no relationship. So we want our p-values to be less than alpha, because we want there to be a relationship. We want to reject the null hypothesis. In this case, we want to reject the null hypothesis. So a lot of times, if there is a relationship, the p-value is going to be 0. So almost all the time, your p-value that you're filling in is 0 if there's a relationship there. The standard error, the error for the sum of the squares, is important because as you saw in the lecture in the slides, that is one of the ways that we use to calculate R squared. And our R squared is relating the total residual error to the model overall to say how good a fit is it. And then our estimator of the variance is also given to us in our Minitab results, and then a space for the regression equation. And then these are the questions to follow, and we'll go through those in a second. But this whole data table is filled in from the Minitab results. So I'm going to switch back to my Minitab so that we can fill this in. So switching back, my regression equation is 13.32 plus 3.324 times taxes. Y equals mx plus b. So our slope, our m that is in our equation here, our slope is that 3.324. So when we look on our document and we want to say what is the predictor coefficient, that's that 3.324. And our y-intercept, see here it says constant, because that's what we're using to calculate sales. So that constant is that y-intercept. And so that y-intercept is 13.32 is that y-intercept there. And so the standard error, the coefficient, we're going to record those in our worksheets and just copy all of this data down. I don't ask for the t-value, I do ask for the p-value, and again, like I said, because there's a relationship there, it's almost always going to be 0. Okay, so you scroll down. So our regression equation we've filled in into our table. Our coefficients we've filled into our table. Model summary is where you get that R squared. And if you listen to the lecture on Minitab, I went through the difference between R squared adjusted, and the R squared predicted. You're just always going to use the standard R squared. So that 76.73 is our R squared value. And so we're going to fill that into our table. And as we come down, when we look at the analysis of the variance, this is actually where we get our estimator of the variance, and we get our the sum of squares of the error. And so it's this line that says error. So it says regression, taxes, error, total. If you remember from the lecture, our R squared was a factor of the adjusted sum of squares compared to the total, right? And so we are actually going to be looking at this error line only. So the only line that you need to look at in this analysis of variance box is the error line, because our adjusted sum of squares of the error is the sum of squares of the error. And so that's 192.9. And so I fill that into my table. And then the mean adjusted mean sum of squares of the error, 8.768. That is our estimator of the variance. And the reason that I have you copying all these things down is because these are all the key data points that your textbook uses for you to do this by hand. This data is showing all of the calculations on the back end that you would have to do by hand if Minitab didn't exist. Based on the data, you would still be able to calculate based on all of the sum of the x sub i's and the y sub i's. You would be able to calculate every single one of these numbers. And that's what the textbook shows you how to do. That's what chapter 11 is all about. It's showing you how to calculate the adjusted sum of squares, the variance, the R squared, the coefficients, the standard error of the coefficients, to test the p-value, to get a t-value. All of those are the formulas in the textbook, and they're showing you how to do that by hand. And Minitab just takes the 2 columns of data and it gives you all of those. The real thing that you're looking for is this regression equation, because this is what we would use to then compare our model to the raw data. And it's what we would use to make a prediction against another value. And that's what we're going to do here on our worksheet. But all of the information that we would calculate by hand is given to us in Minitab. And that means if you ever are thinking, well, this looks kind of funky, why is this answered the way it is? You can look to make sure that everything is aligned with one another. And so one of the things I'd be looking at is the normal probability plot. And this is where I talked about doing that fat pencil test. So you have your computer in front of you. If you have a writing implement, I want you to take your writing implement and I want you to put it right along that red line. And so I want you to hold up a writing implement, put it on that red line, and see how many of the dots you can still see. I see 1 down at -4. Anybody see more than that? I just see the 1 dot at -4, which means all except for like 1 outlier from the data, the residuals of our model seem to follow a normal distribution. And that is a key factor in showing that the model is in fact correctly relating the data points to one another, that there's consistency within how the data points relate to one another. Because when we're looking at the difference, what is a residual? The residual is the difference between what the model says it would be and what the data actually is. And that's why we have these additional questions after you fill in the table, because a residual is showing us how good is our model, how true is our model to the actual raw data. And the better our model is, the more useful it will be to predict future values. But how would I predict those future values? I'd use the regression equation. So the regression equation is what allows me to take any value of taxes and calculate a sales price based on this data that created the regression equation. Now, here's the thing. This is just like we've talked about sample versus population for the entire course. The regression equation is based on the raw data that we use to calculate it. Meaning, if I reduce the number of data points, my regression equation changes. If I increase the number of data points, the regression equation changes. If I'm randomly sampling houses, their tax rates, and their sales prices, the regression equation changes. So just like all of our hypothesis testing, that we look at the probability that that sample in fact aligns with the true population, these regression equations are only as good as the sample data that we use to build them with. So I could build a regression equation. The fewer data points I have, and some of our examples, like our next one, only has like 9 data points. The fewer data points I have, the less robust that regression is going to be, because it's just small. It's based on very few data points, and so it's not very robust to have other predictive powers. The more data I have, the closer I am to building a regression equation that shows the true relationship between the variables. Just like the more data I have going into evaluating sample against the population, the more data I have, the closer my sample will resemble the actual given population, the higher confidence I have. So the normal probability plot helps me to have that confidence that what I'm looking at is in fact a strong relationship, even though I don't have very many data points. And let's see, I have 24 in this case. The R squared value is showing, how often is my data really aligning with, how often is my regression equation data aligning with my raw data. That's what that's showing me there. And then the final thing Minitab gives you, and this is an interesting point here, is that it'll pull out specific observations that don't fit with the rest of the model. And so that's what this bottom box is. You won't actually need it for anything in our assignments, but if you were doing your own experimentation and you were trying to build a regression model, this is really important to look at, because this is showing how many of the observations just don't seem to fit, that they're outliers. And so remember when I said that that 4 down here looked like an outlier to me? Well, this actually tells me what are the statistical outliers. Which of these observations truly don't align with the rest of the data? Because one thing I could do is I could remove this outlier and see if my model is better or worse. And before you just decide to throw away data, it's important to understand why that outlier would be considered unusual. And so Minitab has a couple different codes, but this code R here corresponds to a large residual. It means that the residual for this model is typically 2.18, but for this individual data point, it's 6.317. That's a lot larger than the standard residual. So kind of the average residual that we're seeing based on this model would be 2.18, but this individual observation has a residual of 6.317. So it's possible that this observation should be excluded because it's not really a good fit for the overall data. So questions on that, because reading this is really important to understand what does the data actually mean. Minitab is doing all the work for you. You're not having to do any of the grunt work of the calculations, because those equations in the textbooks, they are bears. Those are difficult equations, and the more data you get, the harder they are to do. But this output totally aligns with what we saw in the text. So let me flip over to my worksheet. That is not my worksheet. Where did my worksheet go? That's the camera off the back of my... There we go. Okay, you guys have to help me out if you're not ever seeing what... Is everybody seeing the worksheet now? Is that what you have on your screen? Thank you, Evan. Okay, so I've filled this out. So I have a predictor, which was my taxes, my response, which is my sales, and now I've filled in my y-intercept and my slope information. So all of this was straight from the table. I've put in my error of the sum of squares, I've put in the estimated variance, I put in my r-squared, and I have my regression equation. And so the next question that I ask is, find the fitted value price for the selling price given that the taxes paid are $7.50. And so this is where I'm going to actually use that regression equation to calculate something. So I'm going to say that sale is equal to 13.32 plus 3.324 times the taxes, because that's my regression equation, y equals mx plus b. And so now I'm going to say that sale is equal to 13.32 plus 3.324 times 750, 7.5, because that's what the question is actually asking. So I'm going to solve. And so crunching those numbers, I get 38.25. Now, in my raw data, it says, what's the residual error between your estimate for the tax rate of 7.5? And I'm going to compare that to the raw data. And so I don't actually have something that's exactly 7.5, but I did have a data point in the raw data that said x equals 7.5422, and that was for a sales price, or a y, of 37.9. And so this was my raw data. And I find that in Minitab, okay? So if I go back to Minitab and I scroll down here, I said, given that the tax rate is 7.5, so I'm going to look in this tax column. And so I'm just going to scroll through all the data points and look for the one that's closest to 7.5, and it's data point 19. And so data point 19 has 7.5422, so that's the closest raw data I can get to. And then the sales price was 37.9. And so I'm going to compare this data to what I calculated. And so, switch it back. There we go. Switching back to my camera here, you can see that what I actually have is my residual for 7.5 is the difference between the two. The difference between what I calculated, which was 38.25, and what the actual raw data was. So I'm going to take the difference between my calculated value minus my raw data value is equal to my residual. And if you remember, the textbook The residual was that little symbol E. It's the error. It's the distance between the fitted line and the actual data point. So what does that mean? What are we talking about here? Well, remember my y equals mx plus b? That's just a straight line, right? And so for every value of x along my x-axis, I have a corresponding value of y. So the model for my y equals mx plus b is 13.32 plus 3.324 times taxes is equal to sales. That's what...
I'm sorry, could
No.
you adjust your focus just a little bit? I'll be okay if you can't, but it would help.
Trying to brighten it up a little too. Oh, that's way in. Is that better at all, Mary? I mean, I can...
Yeah, that would be nice.
If it's big, is it
Yeah,
better?
that helps. That helps out a lot.
Okay.
Thank you.
Sure. So my y equals mx plus b is sales is equals to 13.32 plus 3.24 times taxes. That's my regression equation that Minitab gave me. That is how I'm using it to calculate this value. So given an x value of 7.50, I plug it back into my regression equation and I get my y of 38.25. So 38.25 would actually be on this line. 38.25, and this is obviously not to scale, but I said my x is 7.5, so that's right here. So for an x of 7.25, my y was 38.25. That's what my calculation was based on the regression equation. But what's actually happening here, when I calculate the residual, I'm comparing it to raw data to say, well, what was it actually? My y on my raw data for a value of 7.542, so it's slightly past that 7.5, was lower. It was 37.9. So it's a fraction lower. The distance between these two is my residual. That is that little e. So for every single data point that I have along this line, there is the difference between my calculated value and my raw data value. So if I was to draw this, I'm just going to flip my page over so I can draw it bigger. If I was to draw this, I have a fitted line of data values based on my regression equation. So this line is from my regression equation. But all along this line are the actual raw data points. Now, some of them actually fit the line. That's what the line is made off of, right? So some are on the line. Some are really close to the line. Some are further away from the line, right? So if you can just think that for every raw data X, I have a calculated X. Or for every raw data Y, I have a calculated Y. Normally I'm going to be looking at Y because Y is the response variable. So the difference between my actual raw data y and my calculated y, the difference between those two is a residual. And what a regression equation does is it tries to minimize the sum of the residuals. And that's why the error term is based on the sum of the squares of all of the individual residuals. And so it sums up, that error sums up from y equals 1 to n all of the residuals. And that total here is really my factor of how reliable is this model? How good is this model? Because it's looking at how far away are these data points. And when I sum all those up and average them out, that's telling me how good my data is. That graphically is what this number is here, mathematically. And that's why this R squared is so important. So I can calculate the difference between my calculated value and my raw data to calculate what that individual residual would be. So that's 38.25 is what I calculated. 37.9 is what my raw data says. And so in this case, my actual residual is 0.35. That's the actual answer to the question. But it's important to know how those relate to the overall creation of the regression equation. So for every one of your homework assignments, case studies, and exam, you're going to have to calculate at least one residual. That's going to be part of the assignment. And to calculate the residual, you're going to choose the raw data value closest to that X that I give you. So if I give you 7.5 and there isn't an exactly 7.50, like in this case, it was 7.5422, you just choose the one that's closest to it. And then you do the calculation by subtracting what you calculated up here to what you actually have down here. Now, we could get this a little closer by substituting in 7.5422 in this equation and get that y a little bit closer. I'm going to do that really quick just because I haven't. So I'm going to do 3.324 times 7.5422 plus 13.32. So if I did this equation, I'm just going to write it down here. If I did 13.32 plus 3.324 times 7.5422, because that's my actual data point that I have, I get an answer of 38.39. And so then my residual would be 38.39 minus 37.9. So this is calculated, this is raw data. And so in this case, 38.39 minus 37.9, my residual is actually bigger. So the rounding actually helped me out. But feel free, if I tell you to find something like 7.5 and the actual data point is 7.5422, go ahead and use 7.5422 in the calculation to calculate that total and then use that for your residuals. Either one of those is correct, but you do see the answers are slightly different. So based on the R squared value, the p-value, the normal probability plots, is there a relationship? Yes, there is. Undoubtedly there is. My p-values were 0. My R squared is decent, 76.73. I'm happy with that. And then my normal probability plot, that pencil test, I only had one outlier. So those three things make me say, yes, conclusively there is a relationship between these variables. which is what you're trying to do with a linear regression in the first place. Questions on that? Okay, so we're going to do the next one. I'll move a little bit faster through this one unless you have questions. But it really is just doing the same thing over and over. So our question says a study was performed for deflection of particle board, influence of moisture, and so we're looking at a 95% confidence level. Is there a statistically significant relationship between the humidity of the particle board and the amount of deflection? So before I even open Minitab, I can go ahead and see the way that they're labeled in Minitab I have written here is stress. The humidity that the particle board is exposed to is the stress, and that is related to the amount of deflection. So my predictor, or my X, is that stress, which is a factor of their humidity that's being exposed to. My response is equal to deflection. And that's important for me to look at calculating here. So I'm going to switch back to Minitab so that we can actually calculate these. And so what I'm looking at here is I have data for stress and deflection. Like I said, I've got a really small n here. I've only got 9 data points, but we're going to do it anyway. Go to stat, go to regression, fit regression model. I want to delete these variables there. So again, my response is the deflection, so that's C4, so I select deflection as my response. The predictor is stress. I select that for my stress categories. It is a 95% confidence interval, so I don't need to change anything for that. But I go ahead and double check that it's there. And for the graphs, I want to make sure that normal probability plot of the residuals is checked off because I'm going to copy and paste that into my homework document. So I go ahead and hit OK, and I run the information. So I've got my regression equation, and so that's the first thing I'm going to copy down onto my table. 32.05 minus 0.2771 times stress. So my Y, the amount of deflection I'm going to see in that particle board, is a factor of this y-intercept, 32.05, and then this slope associated with the stress. So I have my coefficients there, and so I'm going to start filling out my table. So for my stress, which is my predictor, I have a coefficient of that negative 0.2771. And the positives and negatives do matter. If you remember the last equation that we had, it was a plus. There was a positive slope. In this one, there's a negative slope, but those, we do want to translate those coefficients. Those positives and negatives should be there. The standard error of the coefficient, 0.0436, and our p-value is 0. And then our constant term, that y-intercept, is 32.05. The standard error of the coefficient is 2.89, and the p-value is also 0. I see those p-values, I feel good about that, but not as good as I feel about that r-squared value, 85.23%. That's a nice r-squared, okay? Because again, this is relating that amount of residual to the total model. So 85%, I'm happy. Analysis of the variance, come down here, and what do I see? I go across the line that says error. So my sum of the squares, my error is 7.827. So I fill that into my table. And the adjusted mean sum of squares is my estimator of the variance, 1.118. So I have my plot, my table totally filled out now. I scroll down, I have my normal probability plot. It just looks so pathetic. There's so few data points on here. It's really kind of sad looking. But go ahead, take your pencil or writing implement, hold it up against that red line. My residuals don't look as nice on this one, honestly. I'm kind of seeing them poke out from behind my pencil. I don't know what anybody else is seeing, but they're not. Maybe if I had a Sharpie, I'd feel better about it, but they're not looking great. But my R square is high. This is really a factor of a small sample size, right? So this is one of those cases where I could add a whole bunch of data points and my regression equation might get worse. My R squared might get worse. This sample happens to show a strong relationship, but would that be consistent if I continued to increase the number of data points? Maybe, maybe not. I don't like sample sizes this small because I think it's like you taking a survey on campus and you walk up to like 8 people or 9 people on campus and ask them their favorite flavor of ice cream. And then you use that data and say, at USI, the favorite flavors of ice cream are, we've talked about that, right? That, statistics can be used. The math is always sound. The math is there, but the smaller the sample size, the less meaningful the data is. And so I don't like the small sample size, but it is what it is. So I have everything I need for Minitab to fill out my equation sheet. So now I'm going to go back to my worksheet and finish filling that out. And we'll see how many times it takes me to get the correct camera. There we go. 3 seems to be the magic number. So predictor was stressed, response is deflection, coefficient, standard error of the coefficient, p-value. That's looking at the y-intercept, slope, coefficient, standard error of the coefficient, p-value. The error sum of squares was from that analysis of variance box that said error, and then the estimator of the variance was also from that analysis of variance box. My R squared had its own box. I like that R squared. The regression equation was at the very top of the data output, so I have that information. If I was doing this for your homework, I would have the first question underneath this table to be copy and paste your normal probability plot and give insight about that. So you would do that. And then I'm going to actually play around with the regression model and see how well this does. And I gave myself no room on this page, so we're going to have to flip it over probably. So it says if the stress level, if X is equal to 68, find the deflection. So deflection is equal to 32.05 minus 0.2771 times stress. I'm going to substitute in my actual value that I was given, which was 68. And I calculate that total, and it comes out to 13.2072. So now it says, what is the residual between your estimate for a stress level of 68? Now, if you go back to that raw data, out of the 9 variables, 2 of them were 68. So I actually want you to calculate both, and that is true on case studies in the exam as well. If I give you an X value and there's more than one of those X values available, then you need to go ahead and calculate both of them. So I'm going to skip down to the bottom of the page because I gave myself no space. So for the first one, I look and I see that for a value of 68, for x equals y was equal to 13.505. And then the second one for x equals 68, y was equal to 11.640. Now, I'm going to draw a little graph again, because I just want to show this here. On our x-axis, we've got a value of 68. For our line that we created, we said that the value was, draw my line, for that value of 68, using my prediction model, my y was 13.505 0.2072. The actual data says for one of them, it's all the way down here at 11. 11.640. The other one's a little closer. The other one is above it. 13.505. Obviously not to scale. So this point here is the regression model. That's on the actual line for the regression model. But down here is a raw data value. Up here is a raw data value. The distance between these two are my residual. So it happens to be that this value 68 actually shows a pretty big residual, because if I take 13.505, which is my data, raw data, and subtract from it 13.2072, I get 0.2978, and then 11.640 minus 13.2072, it's equal to negative 1.5672. So those are my actual residuals. So this is residual 1 and residual 2. But the significance of this is showing that that's a lot of variation there, right? I've got a positive 0.2978 and a negative 1.5672 for the same x value. So how am I feeling about this model? Well, my p-values are 0, my r-squared is 85%, and my normal probability plot looked decent. So in answering question 3, is there a relationship? Yes, there is. That's the answer to that question. Yes. But in reality, I would really want more data. If I start seeing variation like this between these residuals and seeing that at an x of 68, my y can be pretty highly variable, that just tells me like, I don't know how I feel about that. I'd want more data to confirm and get a better model, because that's how I'm going to get a better model, is getting more samples. So if someone came to me with 9 data points and said, set up a regression equation, I'd laugh. That's not really good practice statistically. But the data being what it is, I plug it into Minitab. These are the results I get. It's fine.
Did it tell you to use 68 in part C?
C.
It told you to use 68?
Given
Yeah,
that
okay.
the stress level is 68.
Okay.
And that's how they're all going to be phrased. It's all going to be phrased in terms of the x, because that's the basis of the model, is find a y given an x. So all of them are going to be a value of x that you then plug into your regression model. I think it's good practice to write the regression equation out completely and then sub in the value to calculate it. Obviously, if you just wrote that number, that's also correct. But I think for your homework, for your case study, for exams, especially exams, definitely put this in, because on case studies and exams where they're worth more points, when I see you write this, you'll get almost full credit, even if that is different because you've rounded or made a silly math error. You know, it happens that we just punch things into our calculator and hit the wrong button. If I see you write this down, then I know that it's a math error. If you just give me a number and the number's wrong, I can't do anything with it. So I highly recommend that you write out the equation like this, so that I know that you know what you're doing. And then if it's either a rounding error or just kind of flubbing on the calculator, that you punch the wrong key accidentally, I don't really worry about it. Does that make sense? Same thing for here. You know, go ahead and write the difference between the raw data and your calculated value. Even though the math is simple, when you write it out, if there's any difference, like if you truncated these numbers, the answers would be slightly different. So it's just it's easier for me to give you more points if you've shown me more work. Okay, questions, because that's it. That is linear regression at the undergraduate level. No questions? All right, so for this week, you just have a homework assignment. The homework assignment is a Word document posted that looks exactly like this. And again, it uses the same Minitab worksheet that I have posted in Blackboard. The case study will also look exactly like this. It's just longer. I can't remember if it's the homework or the case study, but you will have examples where there is no relationship. So don't think you're doing it wrong. If your conclusion is no, there is not a relationship, that's okay. That's still the answer. You know, these two examples we did. There was a relationship. The p-values were 0. The r-squared values were pretty good. If you do an example and the p-values aren't 0 and your r-squared is like 30, like then just write no. No, there is no relationship. You're still going to have to go through the process of calculating residuals based on your the equation and the raw data. Like you'll still do the full assignment, but where it finally says, you know, is there a relationship, you'll just write no. And that's an okay answer. Don't think that you're doing it wrong. Because that's what happens in real life, right? That sometimes there is no relationship. You plug it in, the data into Minitab, and they're like, oh wow, no, they're not related at all. That's why we use this. So don't be scared if you get something that doesn't look so nice and neat with a high r-squared value and a p-value of 0. Next week, we will have a synchronous Zoom. I sent out a Google survey for what day and time works best for everybody, just to make sure that, because I figure now that we're coming to the end of the semester, you might have multiple synchronous sessions. So I put out a Google survey. Whatever wins will be the day and time that we use as a group. And then right now I'm planning on opening the exam on Wednesday of next week, because it's due the following Wednesday. So that way you have a full week to do it. I'm not going to wait till the end of the week and just open it like Monday, Tuesday, Wednesday. I'm going to give you guys the full 7 days. So it'll be due May 6th at 11:59, but that way you have a full 7 days. And I know you don't have your exam 2 grades. I don't post them until I'm done with all the tests, and then I upload them together. I'm almost done grading exam 2. I have a few more left, and then I will post all those grades, so you should see those coming up today. The quiz grades were in. I think actually that's the only outstanding thing for your class is the, or maybe homework 10 is still out there. But that should really be what we're looking at from a grade perspective. And I will get those to you. Like I said, hopefully today I'll finish that up and get those all posted. Any questions before I go? All right. Well, again, please feel free to contact me if you need anything, and we'll be in touch next week.